most of the world's population has trouble digesting lactose. I mean, we weren't made to be drinking from a cow. That's really the calf's job. But obviously we've made a lot out of milk products, right? So we've gotten used to ice cream and yogurt and all these different things. But for some people, that's going to be hard for them to digest.
Allergies are a real big contributor to about half, maybe 50 to 60% of asthma, not all of asthma. So I'd like to change the perception that it's all mild and no big deal. Because I think a lot of people walk around with very high symptom burden and they just live with it.
Hello, and welcome back to The Vitals, the Mount Sinai Health System's groundbreaking roundtable video podcast. I'm your host, Leslie Schlachter, a neurosurgery physician assistant here at the Mount Sinai Hospital. Today, we're tackling a subject that touches millions of families, allergies. Whether it's seasonal sneezing, life-threatening food reactions, or asthma triggered by allergens, allergic disease is on the rise. To help us understand the causes, challenges, and latest treatments, I'm joined by two of Mount Sinai's foremost experts. First, we have Dr. Monica Kraft, System Chair of the Department of Medicine at the Icahn School of Medicine at Mount Sinai, and world-renowned leader in respiratory medicine and asthma research. And joining her is Dr. Scott Sicherer, Director of the Elliott and Rosalind Jaffe Food Allergy Institute, and a national leader in pediatric food allergy research and care. So thank you so much for being here. I really appreciate it.
Thank you.
So let's just start off with some of the basics. Allergies are on the rise, right?
Right. So I'll start, and then I'd love to have my esteemed colleague chime in. So our immune systems have sort of evolved over time because our environment has changed. And so we've been living, especially in countries, more first world countries, we've been living in very well-insulated homes. So much so that we get exposed to allergens, every day, especially, at night when we're in our bedroom sleeping for 8 hours at a time. It could be house dust mite, fungal elements, and that is one sort of hypothesis as to why allergies are on the rise because of the exposure piece. There's also really the lack of the other things, infections that really skew the immune system the other way. And so that's been so in general, our immune systems are sort of skewed towards allergic diseases. And so that's another hypothesis. So you put that together with a changed environment.
Wait, time out. So what you mean is we are decreasing our exposure to like bacterial or viral pathogens, which increases our response to more allergic?
In a sense. In the sense we've eradicated a lot of infectious diseases. Right. That doesn't mean we're still not exposed to lots of viruses and allergens because and environmental irritants, we absolutely are. But now we're seeing this intersection between the sort of predisposition to allergies over time because of our environmental exposures, and then the lack of other exposures that might skew our immune system the other way. So in general, that has sort of led to this hypothesis that, in fact, we are moving forward toward an allergic predisposition.
Let's just put things in categories. There's lots of different types of allergies, right? So we have like our seasonal allergies, pollen, stuff like that, anything out in like the environment.
Right.
And then our home allergies, like what are the most common?
House dust. Yeah, dust might be the most common. Fungal elements can be. In some homes, cockroach is an issue.
Okay. And then food.
Mm-hmm.
Various types of food.
Right.
What are the most common allergies?
I would say for indoor, probably things like house dust, and then also pets, cats and dogs for sure. And I say just different fungi like Alternaria, Aspergillus, those sorts of allergens. Okay. But for food allergy.
Yeah, the world of food allergy, there are certain foods that sort of rise to the top of being the most common ones. And we talk about them as the top 9: milk, egg, wheat, soy, peanuts, tree nuts, fish, shellfish, and sesame. They account for like more than 90% of the trouble, but you could be allergic to virtually any food. Those are just the more common ones and some of the more severe ones.
How do you determine the difference between a true allergy versus like a sensitivity?
Well, that's a very
like your
important
whole
question
job,
for the
right?
public. Yeah, because a lot of people say, "Oh, I'm allergic to milk. I can't have too much, or I'll have like bloating, stomachache, gas, diarrhea." Mm-hmm. That's lactose intolerance. That's a problem with digesting the sugar that's in milk. But allergy is really an immune system response. As Dr. Kraft was talking about how the immune system is responding, the problem with food allergy is that the immune system is essentially attacking the proteins that are in the foods. And in that attack, we end up with the allergic reaction symptoms. And so it could be dangerous, and the person usually can't eat the food.
So an obvious one, I'm a neurosurgery physician assistant. I specialize in surgery. The way I see it is the obvious ones. Like my son's best friend has a nut and seed allergy. So I had an EpiPen in my home at all times. That's the brand name. What do you call a non-brand name EpiPen?
An epinephrine injection device.
Yeah. That I know. That's scary. That's anaphylaxis. Mm-hmm. So how do you determine, like, what are some of the most common symptoms of like the sensitivities?
Part of it is
from
Part of it is from the story. So as I mentioned before, the symptoms of the gut problems after ingesting too much milk, the person is having trouble digesting. Most of the world's population has trouble digesting lactose. I mean, we weren't made to be drinking from a cow. That's really the calf's job. Mm-hmm. But obviously we've made a lot out of milk products, right? So we've gotten used to ice cream and yogurt and all these different things. But for some people, that's going to be hard for them to digest. Celiac disease is a very different problem. It's a different illness. It's not like our classical like food allergy, like we think of like a peanut allergy, for example. If you eat too many beans, right? There's a poem that goes with that, right?
Yeah, yeah.
The magical fruit, the more you eat, you know the story. It's because the sugars that are in there are harder to digest and it leads to having gas. But none of those are really dangerous. Those are, sensitivities or intolerance. But the allergy is actually potentially for certain foods and for certain people really dangerous and potentially life-threatening.
So what happens, like what actually is happening in the body during an allergy attack from food?
So the body makes a protein called IgE. I like to think of it as little antenna, that these proteins float around the bloodstream and find their way to allergy cells that are throughout the body. They might be for dog and cat and pollen, or they might be for peanuts or different tree nuts, but they're very specific. Now, if you eat that food that you're allergic to, that little antenna sees it, tells that cell to release the chemicals. And those chemicals, like histamine and others, make swelling happen. It makes the trouble breathing. It makes the heart may not be able to get the blood to circulate properly. So the common symptoms you see are hives and rashes, like mosquito bite-looking rashes, stomach issues like vomiting, diarrhea. This could all come on very quickly, usually within minutes of eating the food. And then asthma-type symptoms, we're going to hear more about asthma, could be triggered at the same time. And then in the circulation, that's anaphylaxis, a severe allergic reaction, potentially deadly. And so it could be quite a dramatic problem.
Well, and the same thing happens with the environmental exposure. So if you have really very, very prominent allergies to environmental allergens, so this time it might be certain trees or grasses, in addition to the indoor allergens we talked about. Go outside, you inhale it, and so the upper airway, the same type of reaction happens. It comes in contact with your nose, and there's a whole cascade of events that starts, including that IgE that knows that allergen and sees it again and tells cells to release all of these contents, and you get lots of swelling. So you might get, rhinitis, difficulty breathing through your nose. But then when it extends to the lungs, it can cause an asthma attack.
Right. So to keep it like super simple, an allergy is something that causes more of like a systemic response, like throughout the body, versus like a sensitivity that might aggravate, one part of the body.
Sort of yes and no. I think milder allergies can cause really more rhinitis and upper airway symptoms, and that's sort of all certain people have. And so they'll get the Flonase, or they'll do the rinses with saline, they'll take an antihistamine, and then they're fine. Then there's some who have much stronger, much more severe allergies that then really involve the lower airway, because there's so much, redness and swelling, just inflammation going on in the upper airway that there's a lot of crosstalk between the upper and lower airway. And when I say lower airway, I mean the lungs.
Yep.
And then the lungs themselves, the airways get inflamed and they get narrowed, and that's why it's difficult to breathe.
How is it that some people have no allergies, some have some, and some have severe? What's the difference in their bodies?
That's a great question. I think it's a combination of things. I think it's your inheritance. So if it runs in your family, the genetic inheritance, there's that piece. But there's also a whole area of investigation going on about how the environment actually changes your DNA and can make you more susceptible to future exposures to those same allergens. That's called epigenetics, and that's a very hot area right now in research, trying to understand that, because some of that can be heritable. You can pass that on to your unborn child, or you yourself can have very severe disease because you've had your DNA sort of changed by this environmental exposure.
So what is the connection between allergies and asthma? Like I remember in PA school, allergies, asthma, eczema. But like, what's the connection here specifically with asthma?
Sure. Well, there's this whole entity called the atopic march that starts in childhood in some patients. Not everyone with asthma had it as a kid.
Can you say that again? Atopic?
Atopic march.
March. Okay.
So it starts out with maybe atopic dermatitis with rash, and then it can lead to rhinitis, which is runny nose and watery eyes, all those types of things, and then lead to asthma. And that's sort of a process that happens in childhood and can move to adulthood. It doesn't always move to adulthood. So there's that side of things. And that's so those early allergens can really set up a whole training of the immune system, if you will, that will then lead to the asthma later in life, usually by about age 6 or 7 for kids. And then some kids manage to do, kind of, quote, grow out of it in their teens, and then they don't really have asthma as adults. But then a good percentage will develop it in adulthood. And it switches genders. It's more common in boys as a child, more common in women as adults.
Do you think that is like a hormonal connection there?
I think it's both. I think it's in part hormonal, but then also it has to do with the lung structure and development.
Okay.
And so it's sort of a combination, an intersection of the two.
Okay. We were talking a little bit before, but we didn't want to jump into it, that there's some misinformation out there about asthma specifically.
Sure.
What is that?
Sure. I think there's this perception that asthma is not a big deal, that everybody knows somebody with asthma and it's mild and it's just not a problem. And I can tell you from the patients that I take care of and having been in the field for a while that, in fact, there is a lot of severe asthma out there and very poorly controlled asthma that leads to very poor quality of life, and in severe cases can lead to emergency department visits, hospitalizations.
It's an expensive condition.
Yes.
Yeah.
And then the inhalers are expensive. There's high copays that can happen. And so I think that there's more to it than I think people really understand. And then allergies are a real big contributor to about half, maybe 50 to 60% of asthma, not all of asthma. And so therefore, it's a really important link. So I like to change the perception that it's all mild and no big deal, because I think a lot of people walk around with very high symptom burden and they just live with it.
Right.
And
or just like keep rescuing it rather than treating it.
Yes, exactly. Getting to
preventatively.
the root cause. Absolutely. They
Right.
don't get the right care, right medical care.
Is that concept that she talked about, like how more common, you said women, girls, and
Yeah.
men, boys,
Mhm.
is the same thing happen with food allergies, or is that totally different?
It's interesting that in the younger age group, there's a little bit of a boy predominance of food allergy. And then as we get into the teen and later years, it's a little bit more girls and women. And we're not exactly sure why that's the case.
Exactly.
Mm-hmm. What about the type of food allergies? Is there ones that present earlier versus later?
So the very common food allergies in the youngest people are milk, egg, peanut, a little bit wheat and soy, and tree nuts. As we look into older age groups, we see more tree nut, shellfish, and fish as being more common. The good news for a lot of the younger children is that allergies to milk, egg, wheat, and soy do tend to be outgrown as children get older.
Mm-hmm.
The not so great news is that the other ones like tree nuts, fish, shellfish, peanut, they tend to be more persistent. So only about 20% of young children outgrow a peanut allergy. Only about 10% outgrow the tree nut or seafood allergies.
I remember, my kids are 17 and 19 now, but I remember being a young mom and there was all this information of like, don't give your kids peanut butter or eggs, or there were all these rules. What would be like your go-to speech for all moms?
Well, everything you just said is wrong now.
Yeah. Right? So like,
there's
what's
been a
the
real
speech?
turnaround in that. So, a little bit of a history lesson on this, but going back to the year 2000, the American Academy of Pediatrics came out with statements about if you're allergy-prone family, don't give that baby milk until age 1, egg until age 2, peanuts, tree nuts, fish till age 3.
Mm-hmm.
And that came out when I was sort of early in my career, and it wasn't very evidence-based. It had some information, but I was like, that means you wouldn't have birthday cake at your first-year birthday. I mean, something's not right there.
Which maybe we should fix that tradition anyway.
So,
Just switch it to like fruit.
So we
True.
learned through we learned through studies that actually earlier introduction of these allergens is actually beneficial and more preventative. So it's really been a 180 turn on this one. So the recommendations now, especially for children who show some of that atopic march signs like eczema early on, it's like, they might end up having more things going on for them. The idea is to get peanut into the diet earlier, so around 6 months of age or 7 months of age, in infant-safe forms, which is its own little story because peanut butter is a choking hazard, peanuts are a choking hazard, so you have to smooth it out. And so we have to give our families instructions about this. But getting this into the diet early actually essentially teaches the immune system not to attack it and has about an 80% reduction.
So that the atopic march, you called it.
Yep.
If you see that, that would be a sign to then reintroduce the food.
So the general idea is not to wait forever to get any of these allergens into the diet, but particularly in a baby that you might see showing signs of allergy, which is typically the eczema or atopic dermatitis, that would be a higher risk infant that's demonstrating to us visually that their skin is itchy and red and allergy prone. That's a baby that especially would potentially benefit from the early introduction.
It's the opposite of what society would say.
Which
I'm
is
so
actually,
glad you're saying that.
Well, that's why it's great to have this as a conversation here, because it was very easy for families to just say, okay, I won't eat these things or not give it to my baby, basically. But doing something active like giving egg earlier, giving peanut earlier is sometimes more anxiety provoking, but it's safe and it's the recommendation now. Talk to your pediatrician.
Well, you remind me of the whole school of thought. There are the families that live and especially in Europe, they live on the farm.
Right.
And the way farmhouses are in Europe, they're right above the barn. So there's a lot of contact with the cows and the pigs. The prevalence of asthma is incredibly low, because those early exposures to certain bacterial agents, in the case of allergy and asthma, is really important. And again, the developing immune system. So you expose the immune system to certain entities early in life and sort of train it, if you will, to not recognize it as harmful. And so
this is really going to upset all those people that still run around with like masks and all these things.
Well, that's a different story, really. But the lesson really is that, as you said in the very beginning, the world changed a lot faster than our immune system changed. And that's sort of where the disconnect is.
Right.
And, if we rolled the clock back a few thousand years, how did babies eat?
Right.
I mean, you'd have to imagine that there was no packaged foods or anything, none of those squeezy things. The mother or father had to chew the food, presumably, and make mushes and spit it out and give it to the baby. That's a mush of a mixture of foods given early with all of the different stuff that was in their mouth without brushing teeth or anything else, and with immune system things that are in your
handed
saliva.
To them in dirty
hands,
so,
probably.
Exactly.
So it's very, it seems like a long time ago, but in evolution, it's not that long ago, and things changed fast.
So we know that research, like even here at Mount Sinai, clinical trials, they save lives. So what's going on right now in the world of research and clinical trials here?
Let me take real quick just off of what we just talked about. So Dr. Kraft talked about how people living where it's more natural, on farms and things have less allergy. We know it was noticed that babies born by C-section have higher rates of allergy than babies who are born vaginally. And going through the vaginal canal, you get all of these different bacteria that are resident in that canal. So finding that those born by C-section have more allergy, a study was designed here and run here where mothers who were giving birth by C-section, it was randomized whether to take some of their vaginal secretions and basically rub it on the baby to seed the baby with those bacteria. And then we're following those infants over time to see if it does have an impact on reducing their getting allergic or atopic dermatitis as an outcome.
Interesting. Well, there's also...
do we know the answer?
Not yet.
And if kids go to daycare, a lot less asthma because they get exposed to all those infections early in life. And it skews the immune system away from allergic disease.
Having a dog in the house.
And a dog, especially in your first year of life, huge impact on asthma and allergies.
Not having a dishwasher.
Yeah.
So, like dishwashers really clean all of the bacteria and stuff off of the dishes and things, right? So that's making it even cleaner in your house. Not telling you that convenience is bad, but these are all little things.
Right. It used to be called the hygiene hypothesis. We now think it's more of the kind of the gut development hypothesis, because actually the way your GI tract develops in terms of its exposure to bacteria has a lot to do with how the lung immune system develops. They're very connected.
So another study that we're doing is giving babies communities of bacteria that we think will be helpful for developing the right immune response to allergens into foods and seeing what happens. I don't have the results of that yet either.
So the treatment for this is kind of like exposing them to, like, okay, let's back up. What is the treatment for allergies? Like treating them acutely and then treating them maybe to prevent or eradicate it?
Right. So it depends on the age. Mm-hmm. So as a young child, there's really some interesting innovations happening for prevention, as you heard. There's also a bacterial lysate out of Europe called bronchovoxome that's been given to 6-month to 2-year-olds. It's got gram-positive, gram-negative, all kinds of bacteria in a powder that you ingest. It's oral to see if that prevents the development of asthma. So those are things that are done sort of early in life to train the immune system. Once asthma is established, then there's the treatment of allergies and asthma. So you want to take really good care of your sinuses. So you do that with antihistamines, nasal steroids like Flonase, and especially if you have anything like nasal polyps, you want to see your friendly ENT physician.
What about like nasal sprays and nasal rinses?
Yes. Yeah, the nasal sprays would be like the Flonase.
Yeah.
And
no, I meant like just even like saline nasal
saline's
spray,
great.
Like the Neomed
I'm a huge fan of the Neomed. You do that first, and that in combination with Flonase is really great. And then if you need to add an antihistamine, either a pill or a spray, there's an antihistamine spray called Stelazine or Astapro. Mm-hmm. That's something you can do to take really good care of the upper airway to reduce the crosstalk with the lungs. So that helps, kind of protects the lungs. Once you have established asthma, there's a number of inhalers that you would use to really reduce the inflammation. And then when it gets beyond that, then we think about the biologics. And that's a whole nother area for more severe asthma that targets certain kinds of inflammation. It's really allergic asthma. Most of them are focused on.
What do you mean by biologics? What is that term?
So we have about 6 at our disposal now, and there are specific medications that are given by injection that target certain types of inflammation. And in the case of asthma, it's going to be that allergic form of inflammation. So it's very specific in its use, and that's why it's kind of termed a biologic.
So how does somebody get treatment for this? They have to have like allergy testing to then see what biologic they would need?
Yeah. So first, the idea is that you kind of figure out what kind of asthma a patient has. So you want to do allergy testing to see if allergy is driving that asthma. Okay. We also have these things called biomarkers. We can look at certain cells in the blood there's a white cell called an eosinophil, which is very much associated with allergies and asthma. We want to see if that's elevated. We can measure a biomarker in exhaled breath called exhaled nitric oxide that's associated with untreated inflammation in the lungs. So we do all these things to figure out, does a particular person have an allergic or eosinophilic type of asthma? Because then that would make them a candidate for these biologics that target that. Some of our patients don't have that. We have other options for them, although fewer. Mm-hmm. And but the ones that have this allergic asthma, we have a lot of choices for them. And then, so we use these biomarkers and the clinical characteristics and the age of onset and all sorts of things to come up with kind of an algorithm of which biologic to choose.
And does that treat it in hopes that it goes away, or does that just manage it?
Well, that's a great question. So they really were developed to reduce asthma attacks. That's the whole point. And maybe improve symptoms, improve lung function a little bit. Now, over time, there have been patients that have done really well with them and have been well controlled. And so we're actually talking about the word remission in asthma, which is so exciting. I never thought in my whole career I'd get to talk about that. And so now there's a movement where can we actually taper the biologic, widen the dosing intervals, can control be maintained? Do patients have to stay on biologics for their entire life? Maybe not. So we're actually designing, one of the grants I'm working on is actually on that. It's a clinical trial to really look at being able to do that in a very rigorous way to see if we can test that hypothesis.
How many clinical trials or research studies are going on right now at Mount Sinai related to just everything allergy? Allergy/asthma.
God, I don't know if I could have counted them up.
I was hoping you'd come up with some
I know.
numbers. I don't know that either of us have access to know exactly how many, but it's got to be dozens.
Oh, for sure. At least maybe 50 to 100, somewhere in there.
And then how do you, adults, it's easy for an adult to make a decision of whether they want to participate or not. But it's got to be hard for parents with children. How do you broach that, especially with food allergies? How do they do it?
We have a discussion. I mean, we're doing a lot of different studies. We advertise our studies through the usual social media means and through our mailing lists. And as we discuss each of our patients as we meet them, to discuss their management on a one-on-one basis. And then whatever opportunities there are for being a participant. I mean, I think of these families are really the heroes. It's not easy being in a study. I mean, there's a lot involved. There's time involved. There's travel involved.
It's a big
and
commitment.
Yeah, it's a huge commitment. And so it's not even just the child, obviously. It's also the parent or parents that are making these trips to come in for different things. We, not being me, but and for food allergy, the entire community of those with food allergy are really depending on those volunteers, those heroes that are taking, their time and some risk to be in these studies to see if what we're doing is going to help them. And happily, we've had a lot of great wins. And, typically we're studying things that we're hoping are going to work and make sense. And we've had some really great wins in that.
Is it the same concept as like the immunotherapy, the biologics, or is it different for food?
There's a lot of different approaches, but some examples. I mean, in the last, if you were asking me these questions 5 years ago, it'd be like, well, the main treatment for food allergy would be don't eat the food. It's pretty straightforward, right? You're allergic to peanuts, don't eat them. You're allergic to cashews, don't eat them. Living like that, though, is like living in a minefield, right? Every meal, every snack, every party, every birthday, everything is around food. And asking questions, reading the labels, checking for cross contact, a hidden ingredient. I mean, that's the way you're living when you have food allergies. It's not easy. The quality of life is highly impacted. There's a lot of anxiety. So, but that's all we were saying, right? But in studies that we've done here, we learned that about 70% of children with a milk or egg allergy can tolerate milk or egg when it's a minor ingredient in baked foods like cookies, muffins. It used to be just don't eat it. And when we had them eating it, we're able to progress them to eventually be able to have the regular forms of the food. And then came oral immunotherapy.
So that's like exposure therapy.
Exposure therapy.
Okay.
And then came more oral immunotherapy, like you're allergic to this, but we're going to give you a very carefully measured small amount under medical supervision. Don't try this at home kind of thing, but under supervision, and then work up gradually where they take the food as medicine, almost like a daily dose. Mm-hmm. We got one FDA-approved product for this, for peanut allergy, but in real life, we're doing this for multiple foods, and we have had more than 1,000 patients that we've treated for this. And we study them also. It's all part of the research that we're doing as well. But it doesn't even end there. I mean, we're looking at biologics, as Dr. Kraft was talking about. One of these biologics was recently approved for food allergy, and it's approved for age 1 and up for whatever you're allergic to, and it raises the threshold. So a lot of people are like, well, it's a little bit of the food would send me to the emergency room or worse. Now on this treatment, I'm able to not worry about that so much because it raises the threshold at least somewhat so that a small accident wouldn't be a problem. And for some people, this treatment that we just finished studying and had FDA approved, this treatment for some people makes it almost like they could eat a meal of the food. So it's quite a change just in the last few years.
So I go back to like my son's friend who has this peanut allergy, and I would have the epinephrine pen. I see you brought them with you. Right now, let's say someone who doesn't manage their allergies, just like they told to have their allergy, they have their EpiPens at home. What do people need to know about EpiPens? And like how to manage that allergy after it happens.
Yeah. So most people are avoiding the food as their management plan. And some people might be allergic to one thing. Some people might be allergic to multiple things. And what they're allergic to is part of how difficult it is to do that. If you're allergic to milk, think about it. If you're allergic to a small amount of milk, you walk into a coffee shop and they're steaming milk, and now it's almost like you've had a lot of dog exposure, dust mite exposure. You might have a pretty bad reaction just from that type of exposure. It's the amount of the exposure in the air. Usually minor contact, like with the skin, doesn't matter, but something like that is a special thing. And milk splatters, spills, splashes, so it's hard to avoid in a restaurant situation. Peanut might be easier to avoid. People are more aware of it and things like that. So all of these are part of the discussion and decision-making with this. But the instruction is to read your labels, to talk to the restaurant. When I have my patient in front of me, I'm spending about a half an hour just going through those types of things of how to avoid getting into trouble with the food. But if you do get into trouble and accidents happen, right, that's the saying, then you need to know how to recognize and treat. So the other half an hour of talking is about, what are the symptoms and what do you do? And if it's just very mild symptoms, maybe we would take an antihistamine, remember, like Benadryl or like a Zyrtec kind of thing. But if it's more than mild symptoms, that's where the epinephrine comes into play. And there are multiple different injection forms of this that you can carry with you and take. It's a very safe and effective medicine. It actually was the medicine that people would take for asthma.
Absolutely.
It's like, hey, doc, my asthma. Okay, here's your injection. Thanks, doc, I'm better.
That's all we had.
Yeah.
Yeah.
Oh, doc, it's back. Here's another injection. But for food allergy, the benefit is that it not only helps any of the airway problems like it does for asthma, but it helps the heartbeat strong. It really helps to stop the reaction from progressing. And it gives you time to get to an emergency room for a bad reaction so that they can get more care at the emergency room
So
if
they don't
that's
just
necessary.
need to do the EpiPen and then just, that's it?
So
they typically need to go to the hospital?
So I'm very careful not to say use your epinephrine and go to the hospital, because people hear that and think, oh, the epinephrine must be dangerous. I have to go to the hospital if I use it. So I never say what you just said, because that's what people take home. And then they're like, I'm afraid to use this. It's a safe medicine, right? So if you use it, it's going to make you feel better. But if you're having a bad allergic reaction, sometimes symptoms could come back, and you don't have maybe more medicines and oxygen at your house, so you go to the emergency room. I could make a nuanced argument and say, well, you gave it, you're all better, you're near an emergency room. All right, don't go to the emergency room. But in a lot of individual cases, if someone is vomiting and has hives and is feeling sick, even if the epinephrine made them better, they're probably better off going to the emergency room.
It's like an asthma action plan. You have a bunch of steps that you do when the symptoms get worse. And then if they're controlled, then you're fine. But if they're not, then you need to go to the emergency department.
What's the difference between all the ones that you brought?
So they all have the same medicine. They're just different forms for injection. And so this guy is shaped the way it is, and it talks, actually. It says what to do to use it. Mm-hmm. The other ones are more like magic marker size.
The pen ones.
Yeah, but they all have slightly different. This is the most common one. And as a brand, it's called EpiPen. The cap comes off the back to unlock it. The other tip goes into the side of the leg, into the thigh. Mm-hmm. You press, count to 3. You'll hear it click. I'll do that now. 1, 2, 3, and then the needle you never see, but it goes in, gives the medicine, and it goes into the leg. There's a new device that is a nasal epinephrine.
Looks like Narcan.
Exactly. It's the same exact delivery system as Narcan. And so it's a needleless version that just was approved. So our patients carry these with them because you never know if there's an accident. They learn to use it if they're having more than mild symptoms. And if needed, they get to the emergency room for more care. This is the emergency plan, just like there's an asthma action plan. This is sort of the anaphylaxis
right. And for one of our biologics, omalizumab, they carry an EpiPen as well.
So omalizumab is the medication that I was referring.
Yeah, Xolair.
The brand name is Xolair. Yeah. It's the medicine I was referring to before that improves threshold for people who have food allergy. And so it's been around for asthma for more than 20 years, so it has a really good safety record. And that's part of the reason why it was approved for age 1 and up. The little story I gave you before about those antibody antennae that are floating around and going to the allergy cell and sitting there kind of like in a cup holder. They pop off, they pop back onto their cup holder, and they're looking out for, is that peanut coming my way? As they're popped off, this medication kind of tackles them.
So it's a blocker.
And at least partially inactivates
Binds to it.
So that you don't, if you have an exposure to the food, it's less likely that you would have as much of a reaction.
Mm-hmm. Yeah. So this is, it's got to be really stressful for not only adults, obviously, but for children to grow up with this kind of chronic illness, this chronic disease. How do you guys see this affecting your patients and their families? It's got to be pretty psychologically
It can be,
difficult.
Yeah. Well, especially if there's frequent hospitalizations, emergency department visits. And if there are multiple children, then if one has really bad asthma, then that child is going to get a lot of attention because of it. And sometimes the other kids aren't really so happy about that. And so it changes family dynamics a lot. And then some parents have a hard time. As you can imagine, it's really stressful taking care of a child that has a severe disease, whatever it is. Mm-hmm. And so and how it affects one's quality of life overall and family life and that side. So there's I spend a lot of time because I see also younger asthmatics as well, sometimes in the adolescent age and then above. And so we have those types of conversations, especially there's exercise-induced asthma where sometimes the kids want to play sports and then they can't. And so how do we help them get over that so they can have a reasonable quality of life too and achieve what they want to achieve?
Do we offer support groups or any social work support for families and children?
We do, absolutely. And on the adult side, if you have especially severe asthma or COPD, there's definitely support group. There's a Better Breathers, which is through the American Lung Association that really offers that. It's been a very nice resource.
So one of the things that we learned during COVID and then obviously every flu season is those with underlying conditions are predisposed to having a more difficult course if they get sick. Is it the same? I know for asthma, that's true. Like asthma is a huge risk. What about allergy? Is that also a risk?
Food allergy in general, it hasn't been a risk. Yeah, there was a lot of worry about that when COVID started, but we didn't see an increased problem.
Well, if anything, we've done some work in my own lab which suggests that having certain kinds of inflammation actually can confer some protection against SARS-CoV-2.
How does that work?
The certain proteins that we make in the allergic situation actually downregulates one of the receptors that the virus uses to enter the cells, ACE2. And so you see a lower expression. Now, whether the challenge is, I think, as the asthma becomes more severe, that balance may not be there. But in the milder asthma and allergy, there may be some protection.
Okay. What about kind of disparities, socioeconomic? Can you talk a little bit about how treatment, getting the right help for these conditions might differ in different communities?
Oh my gosh, yeah,
we might not have enough time for all of that,
right.
But
of course, it's a big issue. Well, especially where we are here at Mount Sinai Hospital, we're juxtaposed between some of the wealthiest zip codes in the country and some of the big areas of largest disparity. So I feel like I see that every day in my own practice because I see patients from all walks of life, and I think in addition to the access to care, there's also being able to pay for medications because the way our healthcare system works with co-pays and such, that can be a barrier. Then there's also what's associated with where you may live. And so we've been getting very interested in geospatial mapping and trying to understand what other exposures patients have in their home life, whether it be the indoor allergen, things like the cockroach, versus if they live near a freeway. It could be oil, it could be some kind of electrical plant or other places where there's exposures that can also affect the airway on top of allergens. So I do think that there's a lot to be concerned about when it comes to disparities. It's not all patients can access the care equally.
Right.
In the world of food allergies, we do see a higher rate in more disadvantaged groups, and the diagnostics are not as up to par, and actually participation in research is not equal to the community that's affected by food allergy. So we're actually doing studies now to try to address that, to learn more about it. The studies that resulted in the FDA approval are mostly, richer and whiter communities that were involved in those studies.
That's so unfortunate because, to participate in research, generally, it's not going through insurance. Right. You can just participate. Right. That feels so backwards.
Yeah. So we specifically are trying to find ways to combat that and really make sure that there's more inclusivity.
I'm glad to hear that because I think in our world, we actually really see a lot of folks from all walks of life who come and do our studies. So from disadvantaged and not so disadvantaged. So we feel like at least that allows access to care because they'll often get their medications taken care of, their background medications, especially if we're testing a new intervention. So and then they sort of become our patients too, which is nice.
I mean, in a perfect world, that would all make sense, but that goes back to trusting the medical community. And then, so here we are, we want to get patients in that need our help. They might not have insurance, but here, come do this research. That can sound fishy, but it really isn't.
Exactly. So I think we've learned a lot about recruiting especially in the New York community through a study that I'm involved with called All of Us, which is a genetic study where pretty much it's not difficult to be part of, but you get your genome sequenced, you get your results back, and then the information goes into a big, very much a de-identified repository that has genetic results, electronic health record, so scientists can use that, scientists from all over the country, to really understand genetic origins of disease. So that part's great, but gaining the trust of the community.
You're going to use my information.
To come in, exactly.
To give to the government.
So we have some amazing community researchers here at Mount Sinai who have very established relationships and have community boards, and they actually guide us. And it was really through All of Us I got a lot of exposure to this. It's been amazing.
How many participants are there in that so far?
Overall, in the whole country, there's about 800,000.
Wow.
Because the idea is to get to 1 million, but almost 900.
Yeah, almost there.
And I'm really proud of Mount Sinai because we've been some of the best recruiters of all the sites. So really proud of the team. They've been amazing. And part of that is because of these wonderful community relationships that we have.
Yeah, that seems to be the key, getting into the community, building trust.
Absolutely.
So that we can treat and save lives.
And that takes a while.
Yeah, it sure does. So we talked a little bit about your allergies and exposures and responses can be different based on where you live, like on a farm versus in a city. Can you just go a little bit deeper into that and how our bodies react to that, maybe for better or for worse?
Sure. I think that the whole presentation is a combination of your own genetics and then your environmental exposure. So it's a real gene by environment interaction. And I want to tell you about one study that I think is fascinating and it kind of epitomizes that, because we'd always felt like the farm exposure was critical early in life, and that can really train the immune system, as we talked about. But there's also the genetic predisposition as well. So there are two populations in Pennsylvania called the Amish and the Hutterites. And they are actually very similar genetically, but then the Amish use very low-tech approaches to farming with oxen and such, and the Hutterites use very high-tech approaches. And the prevalence of asthma is incredibly low in the Amish community, much higher in the Hutterites. So again, attesting that this farm life is valuable, regardless of your genetics. But then the investigative team, they're out of Arizona and Chicago, University of Arizona, University of Chicago, have gone a little farther and collected the dust from the Amish homes and trying to find what is it in the dust. And it turns out it's a certain protein that's associated with a much lower rate of asthma. And so the question is can you actually extract that protein and turn it into a treatment, which that's something down the road, but they're getting much closer to identifying what is it about that population that really allows for much less asthma and allergy, to that matter. So I think we're getting closer to trying to understand that relationship.
So what I just learned is instead of us all buying like air purifiers, we should be buying like air protein dispersers with like cow dander. Basically.
That might make it hard to live in your apartment, but I like the good. That's the right concept.
That's kind of the concept that I learned today is like the opposite of what we all, I don't live in your world of allergy and asthma. And everyone wants to like clean hands, don't eat food off of this, protect yourself against everything. Right. But instead, it's exposure to the thing and to the food that's actually going to help.
Dirt is good.
If you can't get a cow in your apartment, you at least can get maybe a dog.
Get a dog.
Yeah.
If you're not already allergic to
get
it.
a dog.
Yeah.
Yeah. Which is like the opposite. I can't have a dog because, it's so backwards.
Exactly.
Yeah. If you guys can both just kind of think about your patient, someone that a situation in which everything that you've learned and over the years with research and trials that like really helped someone.
So at the Jaffe Food Allergy Institute here at Mount Sinai, we've been doing studies for therapeutics for food allergy. We're looking at like a patch, like a nicotine patch, but for food. We're looking at doing small amounts of the food in dosing or under the tongue, or different types of vaccines that we've been looking at, different biologics that we've been looking at, and in combinations. But one of the things that was a little bit ignored is that not everybody is super allergic to the tiniest amount. And so, for example, with peanut, the average person with a peanut allergy can already eat one peanut or more before they start to have an allergic reaction. And while they're bite safe, like from a really small amount, they still have to avoid the food. So we took that concept and said, what if we did feeding with regular supermarket measured peanut, like peanut butter, and gradually had them increase the amounts if they already sort of were bumped up to begin with. And about half of the peanut allergic population is like that. So we're talking about like hundreds of thousands of people. And so we did that study. We randomized people to either continue avoiding like they were or to have this treatment. And essentially everyone who was in the treated side was able to progress without much side effect at all, was able to get up to like peanut butter sandwich amounts, was able to start to eat it like a regular food in the diet, was able to take breaks from eating it as not a medicine all the time and just eat it periodically. And they were still able to ingest the full amount of peanut. And so we have these families where the children who were, not able to eat the things at the birthday parties and were asking a million questions at the restaurant are now very comfortable. Exactly. Yeah. Are now totally comfortable in eating the food. I wouldn't call it exactly a cure because, we still do tell them to try to keep it in the diet periodically. But they're really living a normal life with this now.
That's amazing. Wow. What about you?
So I see patients at the Respiratory Institute, and we have a whole asthma and allergy center for adults and work with several people. We have a full service setup. And I have to say, I've always really loved as you asked me about a patient, I had to think back because I have a lot of them. But there's one in particular since I've come to Mount Sinai that stands out. And so very, very severe asthma, multiple trips to the emergency department and hospitalization, and was using inhalers, but sometimes would forget to use them, and finally got to me. Because a lot of times I get referrals as a pulmonologist. And so I sort of sat down with him and really kind of explained the whole nature of asthma and why it's important to take the inhalers regularly and not smoke or inhale other things. And so we developed this relationship over time. And then eventually he needed a biologic. And he was very scared of needles. Because a lot of all the biologics are injectable and you inject them at home. And so we teach you in clinic and then you take it home. And he just didn't want to do that. So I actually brought him into the infusion center every couple of weeks to get the injection. And just through building that trust and having him try it, he has done so well. He's been out of the emergency department. I give my patients my cell phones so that when they get sick, they can contact me quickly. I only see him at appointments now. We don't talk in emergency situations because he's done so well. And I got the sweetest note from him about just thanking me. And so, but I feel like that's my job. I enjoy it, but it's the wonderful part of
but you
what
need them
we
to
do.
participate.
Exactly. So he was willing to partner with me because I always tell my patients it's a partnership. So I can give you the tools, but then I want you to meet me halfway.
Right.
And if you're willing to do that, we can do some great things. And so it was just really gratifying to see how well he's done.
Awesome. So you talked a little bit before about exposure to bacteria and virus. Do you think that bacteria gets a bad rap?
I sometimes think it does. I think it's context dependent.
Right.
Because clearly if you've got an underlying severe disease, but I'm going to say lung disease because that's my area, that yes, exposure to certain bacteria wouldn't be in your best interest when it's an already established disease. So then you want to be protective. However, early in life and throughout your life, if you have issues that aren't as severe, bacteria can actually be your friend.
Right.
And so I think understanding those different scenarios is important. They're not all bad.
Right. Yeah. Is there any new information or new thing that you want to share with clinical trials that are happening here at Mount Sinai?
I'm glad you asked. Yes, I would love to. We have a lot of trials going on in all disciplines, and you heard about a lot today in the allergy space and asthma and food allergy. But I wanted to also make sure that our listeners heard about all the changes that we're making to clinical trials infrastructure so that we can really offer them across our health system. Because we feel like it's really important for patients to have access to new therapies, to care. And so we're really looking at all aspects of what it takes to get trials up and running. From things early on in contracts with sponsors, whether it be from industry or NIH, all the way to space and making sure that patients can easily access trials wherever they live in New York.
So what does this mean for what might or may not happen in the government with related to?
It's agnostic in that we do trials funded by NIH, but we do a lot with pharmaceutical companies as well. Mm-hmm. And so if anything, we want to partner with a lot of these companies and strengthen our NIH portfolio. So we really are going both ways. So
Awesome.
This has relevance to both.
Awesome. Great. Thank you. What would you say are the top 3 things that you want the listeners from today to take home from what we talked about? Like the 3 things, like public service announcement, you should know these 3 things.
In the food allergy world, some things to remember. So one of the questions you asked before was about the impact on day-to-day, like quality of life. And food allergy is a little odd because the child or adult just looks perfectly fine every moment of the day. And yet every meal, every snack, every social event involves food. And so this anxiety is there. And a lot of times, just like you were mentioning about asthma, the myth of asthma, it can be really bad, and it's not a little thing. A lot of times the public ends up looking at it like, oh, you're just making things up, or this is not such a big deal. And that can translate to bullying, which we've seen children experience. It could translate to maybe someone at a restaurant not taking something seriously and ending up with a problem, or even maybe some friends or relatives who are not making the right connection and keeping the individual safe and cared for and felt like this really is a problem. Right. So understanding that it really is a significant problem is really important. And then probably the 2 biggest other things is that there are treatments now. And so talk to your doctor about that. And I think a lot of people self-diagnose food allergy, or they're confused about allergy versus intolerance. And that might mean that you're avoiding something you don't need to avoid, or it might mean that you're not avoiding something that you should be avoiding because you thought you were allergic to one thing and it turned out to be something else. So it's really important to see an allergist and to get the right diagnosis and to get the right advice.
Awesome.
So I would say sort of along similar lines that don't discount allergies or asthma. It's not all mild, and it can really affect quality of life and your ability to really achieve all the goals you want to achieve. So don't discount it. Get help. Talk to if you have a primary care physician, which I hope you do, talk to that physician and get referrals and make sure that they understand how it's impacting you, and get to an allergist or a pulmonologist who can really take a deep dive into these issues. Because there are so many amazing therapies that they can be life-changing, and don't lose out on those opportunities. And so be assertive about it. It's okay, because sometimes allergies and asthma are discounted. It's not that important. There's so many other things to think about. Hypertension, coronary, not that they aren't important, but let's focus on the fact that you can get really great help, and don't be shy.
Awesome. Thank you guys so much for being here.
Thank you.
Thank you for having us.
Yeah. That's all for this episode of The Vitals. I'm your host, Leslie Schlachter, a neurosurgery physician assistant here at the Mount Sinai Hospital. Don't forget to subscribe to The Vitals and Mount Sinai's other video programming on YouTube, Apple Podcasts, and Spotify, or wherever you get your podcasts. Share this episode with anyone that you know that's navigating allergies. Anyone you know, period. To learn more about the Elliot and Rosalind Jaffe Food Allergy Institute, or to get you or your child enrolled in an allergy test or clinical trial, scan the QR code on your screen. To learn more about clinical trials relating to asthma and allergy, click the link in the description below for the Mount Sinai National Jewish Health Respiratory Institute.